Hi there, and welcome back. What we're going to do in this video is evaluate a limit that has yet another indeterminate form. In this function, so we have x to the third times the natural log of x. As x gets close to 0, x to the third gets close to 0, and the natural log of x drives down to negative infinity. So this qualifies as a limit of the form 0 to infinity. So remember our strategy for this kind of limit, we rewrite one of them as a reciprocal so that it's a rational function so that we're able to use L'Hopital's rule. Because 0 times infinity can either be written as 0 divided by 1 over infinity or infinity over 1 over 0. We consider 1 over infinity to be basically 0, and we consider 1 over 0 to be basically infinity. So basically that just means flip one of them. So which one do we want to flip? Do we want to flip the x to the third, or do we want to flip the natural log of x? And thinking about derivatives, because L'Hopital's rule involves a derivative, it's much easier to take the reciprocal of x to the third than it is to take the reciprocal of natural log of x. So we're going to write the natural log of x divided by 1 over x to the third, which, remember, thinking ahead about derivatives, is the limit as x approaches 0 from the right, natural log of x over x to the negative 3. Okay, so just to double check, by rewriting that, what have we done? Natural log of x still drives off to negative infinity, but 1 over x to the third, you get 1 over a very tiny positive number, which ends up being a large positive number. We have infinity over infinity, and we're ready to use L'Hopital's rule. So to use L'Hopital's rule, we apply the derivative to the numerator and the denominator. So this is the limit as x approaches 0 from the right, 1 over x over negative 3x to the negative 4. Now, it would seem that we're at a crossroads here, but remember, now we have powers of x. We can simplify this very nicely. So this is equal to the limit as x approaches 0 from the right. We have 1 over x over negative 3 over x to the fourth, which is the limit as x approaches 0 from the right, 1 over x times the reciprocal of that fraction, which turns out to be the limit as x approaches 0 from the right of x to the third over negative 3. We can now use direct substitution for this limit. We get 0 to the third over negative 3, which is just 0. So the limit of that original function is 0, and you can easily check that by looking at a graph. The graph would make it look like it's passing through 0, 0. It's just getting so close to that point that it just looks like it. And there we have it.